Okay, so now I'm going to use this. I have to guess, kind of, for me. I've got to guess what this chart is going to be. So now there's going to be one lone pair in the middle on the central atom, and there's going to be 3 atoms bonded to it. So I'm going to go back to here, take this off, and I'm going to put on a lone pair. And what do you think the angles are going to be here? Just think. What do you think it's going to be? Pow! 109.5. But now we have a slightly different molecular shape, since these atoms are in this kind of, it looks like a pyramid almost, like a 3. Oh my god, it's called trigonal pyramidal! Yeah! Trigonal pyramidal. That's the shape, the molecular shape. So the shape of the atoms that they make, that's a shape. But the shape of all the electrons, well, that's still tetrahedral. Still 109.5. Okay? So convince yourself of that. And I'm going to go back and fill in our chart. So tetrahedral, the molecular geometry is now something we call trigonal pyramidal. And the bond angle is still 109.5 degrees. Right, so now we're going to go for 2 lone pairs and 2 bonds. So I'm going to take this off, and I'm going to put another one on. What do you think the shape's going to be? 109.5. This is a weird looking thing, right? Some people say, "Oh, look, there's dead mouse." No, this is a shape of a molecule. It's very, you require this molecule like crazy, and it's just a function every day. It's the shape of water. So if that's oxygen, these are hydrogens. Those would be the 2 lone pair electrons for H2O. This is what it looks like. It doesn't look like a straight linear molecule, as you might have thought. It's actually, we call it the shape of this molecule, we call it bent. The electron shape, that's still, the electron geometry, that's still tetrahedral, right? It's still in that tetrahedral shape. And the bond angle is still 109.5. But the molecular shape now is bent. So we can say that the electron pair geometry, sure, that's tetrahedral. But the molecular geometry, there's a scientific name, bent. And the bond angle is 109.5 degrees. Okay, here we go. We're going to do NH3. NH3 is a strange molecule. Did I mean NH3 there? I don't think I meant NH3 there. Let's see, what did I mean? I think that's really the only ones that we need to do. Yes, I'm going to say that. That's as far as we need to go on this chart. We don't need to go any farther on this chart. We could do more. I can show you some of these right now. Let's try this. Let's try with 5. There we go. 5. You get 90. 90, 90. And then 120. Look at that. So those atoms are separated by 120 degrees. See, it's like this right here. This looks like a triangle. And then on the other axis, they're separated by 90 degrees. So it's a little stranger. It's called trigonal bipyramidal, but we don't really need to know that one. If you want to, you can stick as many as you want on here. Well, that's the maximum it can do. Here we are. This is an octahedral. And you can just play around with these, but we don't ever get up to these. The most common ones that we're going to do, there's a cool one. 90, 90, 90 on that axis. And then on this axis, they show it. No, they don't show it. So it's just 90, 90, 90, and those 2 lone pairs are separated right there. It's pretty cool. Anyway, I'm just going to say that's the end of what we need to know. We can just cut this thing off right here. We don't need to know this. I have that on there as extra. Okay. So you're not responsible for that, but you are responsible for this top part. You need to know how to use this chart. So if you have, let's think about how you might use this chart. You look at the central atom, and you see how many electrons are there that are just lone pair electrons. Okay, so here's 0, 0, there's 1, 0, 1, 2, and so forth. Then you look at the number of atoms that are bonded to that central atom, and from there you can read this chart and figure out what the shape of this chart is going to be. Okay? It should be pretty straightforward. Let me know if you have any problems with it. You can take a look at this simulation. It really helps the molecular shapes simulation. Play around with that a little bit and get some intuition for what these shapes will look like in 3 dimensions. So these are really what atoms look like. You can also go and look at the bottom here. They allow you to take a look at what the real molecules, you can barely see it, but that button right there. You can look at what H2O looks like, and there's a model of it, but look at the real one. CO2, look at that. You got double bonds. We didn't even talk about double bonds, but it's really the number of atoms that are bonded to it, into the central atom. There's only 2 right there, so it should be linear. You can look at SO2. That's a pretty cool one right there. I don't think we went through that one so much. We went through... yeah, okay. And then we went to... We can look at some other exotic looking molecules right here. That's xenon fluoride. Sulfur tetrafluoride. Sulfur hexafluoride. This one is pretty cool. We used to have one of this, a whole canister of this in the lab. If you inhale this, there'll be a gas. If you inhale this, it makes your voice go really, really, really low. So Mr. Greg likes playing around with this quite a bit. But the bad news about this is that it's so dense, so heavy, that it's hard to get it out of your lungs once you breathe it in. So you kind of feel a little lightheaded and you can pass out pretty easily. Anyway, that's a couple of shapes. And I hope this made sense. Let me know if it doesn't. I'll talk to you soon.